In this video, we are going to solve these radicals. For your own benefit, pause the video, try to solve them alone on a piece of paper, and when you finish, resume watching the video for the answers. As for the first one, as we see, we have radical 7 plus 3 radical 5 all squared. Here, the power 2 cannot be distributed over addition. In fact, this is a remarkable identity a plus b all squared, which is a squared plus 2ab plus b squared. The a is the radical 7 and the b is 3 radical 5. Okay, so keep in mind the power 2 cannot be distributed over addition. So we cannot directly say power 2, power 2. It is a remarkable identity. Radical 7 all squared is 7, and here we have 2ab. This is one part, one answer, okay? Numbers outside the radical multiplied by the numbers outside the radical, thus getting 6. And as we know, multiplying radicals, the radical inside the number inside the radical multiplied by the number under the radical in order to get 35. Here, what do we have between 3 and radical 5? We have nothing. When we have nothing, it means multiplication. So the power 2 can be distributed over multiplication. So it is a 3 power 2 times radical 5 all squared, which is 5 times 9, 45. And again, now when adding up radicals, we can add same families together, the family of numbers and together and the family of same radical together. So the final answer will be 52 plus 6 radical 35. As for this one, here we have radical 7 plus 3 radical 5 into radical 7 minus 3 radical 5. Note that we have radical 7, 3 radical 5, 3 radical 5, which is a plus b into a minus b, which is another remarkable identity, which is equal a square minus b square. Applying the rule, we get 7 minus 9 times 5, which is 7 minus 45, thus getting minus 38. So before directly calculating, check out the given in order to see if it's a remarkable identity, yes or no. We have the same. Once plus, once minus, it is a plus b into a minus b, then it is a remarkable identity applying a square minus b square. As for the second one, here we have 2 open bracket remarkable identity minus 3 remarkable identity. This is a minus b all squared, and here we have a plus b into a minus b. This is a square, so radical 5 power 2 is 5. Then we can say 2 times 1 is 2 times radical 5 is 2 radical 5, and then we have b squared, 1 squared is 1. Keep in mind to keep the 2 outside waiting and keep the parentheses. As for the minus 3, we keep the minus 3, and then a plus b into a minus b is a square minus b square. A square is radical 3 all squared is 3 minus 1 squared 1. 3 minus 1 is 2. Then we can add up integers. 6 minus 2 radical 3. Then we can expand the 2 and here expand the 2, thus getting 12 minus 4 radical 5 minus 6. Then we can add up the numbers and keep the family of radical 5 because we don't have anything to add it with it. As for the last one, we have 7 into remarkable identity minus 3 into remarkable identity. And this is a minus b all squared and a minus b all squared, which is a squared minus 2ab plus b squared. Applying the rule, we can get the answer, which is 4 times 3 minus outside 4, inside 15, power 2 radical, which is 5. The same thing here, which is power 2, and outside 6. Then we get radical 10 plus 9 times 5. Applying the normal calculation,